This video is going to look at how we generate an electrical impulse along the axon of a neuron. All right, so here's kind of our setup here. So out here we have sorry, we're at the axon here. So the resting potential sits at a -70 here. So what that means is the outside here is more positive than the inside here, which is less positive. Okay. Um, Sometimes you look at it as this is being negative, this is positive, but that can get kind of confusing with the charges. So I kind of like to look at it that way. So this is being maintained at a steady -70, and how that's happening is the sodium-potassium pump is working to maintain this. So it's moving basically 3 Na plus, it's moving 3 Na plus out, and in order to do that, it's got to move 2 potassium ions in. So eventually this sets up a situation where the, the, the membrane potential sits at a -70. So you have basically a higher concentration of Na here, a low concentration of Na plus here, and you have a high concentration of K plus here, and a low concentration of K plus here. Okay, so this just goes like this until this neuron gets stimulated. So if it gets to -50, then we get a huge spike, and that is depolarization. Okay, so that is called depolarization, which is happening on the graph right here. Okay. Um, so what happens to depolarization is the sodium potassium pump's still doing its thing, moving 3 Na in, 3 Na out, 2K plus in, but this voltage gated channel, which was closed right here, opens here. Okay, so it pops open, and what happens then is sodium can now enter the cell. Okay, so the inside then becomes more positive, and the outside becomes less positive, right? Or you can look at this as this becomes negative, this becomes positive. And as a result, the membrane potential flips. Okay, so it flips around, and basically that's kind of the start of an electrical impulse. Okay, and when that voltage gauge channel opens, the sodium is allowed to go inside the cell, and that's what swaps it. Okay, now then what will happen next on that graph is it'll start to go back down. Okay, and that is called repolarization. Okay, so that's that section there. Um, so what happens here then is once we get to a certain high or a certain positive thing, you can see right here the voltage gated sodium channel snaps shut, but the voltage gated channel for potassium opens up. So now what happens is potassium moves out, right? Because remember, It's a high concentration of potassium here, a high potassium concentration here, and a low potassium concentration there. Okay, so what slowly happens here is this becomes more positive, and this becomes less positive, or we could say that this becomes back to what we were at, as in positive, this becomes negative. And you can see that on the graph here as you hit a point, and then it snaps back down. Now, just the way this is, because of this, it actually dips a little bit below, and we say it overshoots, and then it kind of snaps back up. Now it overshoots because basically all that potassium leaks into or goes to the outside of the cell. So that causes the action potential actually to drop below -70. So that resting potential then needs to be reestablished. So that's this section here, which is kind of this section on here. Okay, so when it's reestablished, basically what's happening here, notice both the potassium and sodium voltage gauge channels are closed, and the potassium pump, it's still working. And what happens here is the 3 sodium, they get moved out, and the 2 potassium, they get in, basically slowly cause this to go back up to the resting potential, and that's reestablished. So the dip here is really due to the excess K plus ions. And then as those are basically moved back in by the sodium potassium pump, things get equalized, okay? So this graph is something you actually have on, sorry, let me find, on what we call an oscilloscope, okay? So what you can do, here's a neuron. You take these tiny little electrodes, you imagine how tiny they have to be. You can pop one inside the cell, the axon, and one outside. And then you can measure the currents, right? So here's kind of the action potential firing. Okay, so that's called an oscilloscope, and that's how we measure that. And here's what an old one looks like. You can see the action potential. Well, that's not an action potential. That's measuring heartbeat, but you get the idea. Now, the thing to remember here is like what I just explained happens on one section there. Okay, but then what happens is that triggers the next section to go. That triggers the next session to go. And you can see that represented right down here, and then here, and then here. And what actually happens is sodium ions here kind of leak over to the next section, which leads to depolarization. And then the sodium ions here leak over to the next section, which leads to depolarization. So it kind of goes in almost a wave. But as it moves, notice things are repolarizing, and sections of that axon are going back to a resting potential. All right, so I hope that helps kind of explain this propagation a little bit better and how it's propagated, okay? Thank you.